In this video, we're going to see how to use Oscar to draw out a radical reaction. For radical reactions, we have to use the single electron so-called fishhook arrow. So here's a simple bromination of ethane under the influence of light. What does the light do? Well, it serves to initiate the reaction of breaking the bromine-bromine bond. So let's first draw out the initiation step. So we take a mold of bromine. I'll just steal this one here. Draw out a reaction arrow, and we need some light, so use text for light. So here's our reaction conditions. One molecule of bromine hit by a photon will supply the energy to break the bromine-bromine bond. Now, how do we show that? We use the fishhook arrow. It's going to be the blue arrow, and for a blue arrow, what you do is one electron at a time. You show that the electrons divide, and one electron goes to each bromine. Again, you can adjust these things and make them look the way you want. Now, when that bond separates into two radicals, you just get the two separate atomic bromines, essentially, with a free radical. So I got the first one. I can duplicate it and make a second. Okay, so there we've split the bromine bond. Now, this is going to react with the ethane. So I need a mole of ethane. Bring it down here, and in particular, it's going to react to the hydrogen atom. So I need to draw in one of the hydrogens explicitly. And so again, a reaction arrow. And now one of these bromines is going to react, so I'll come down and grab this one right here. Now, this is going to show that this radical basically attacks the hydrogen, leaving behind a radical on the carbon. So for this, we're going to have to draw three arrows. The first arrow is showing that we're going to split that single bond, and when you saw in the middle there that one half showed up here, that just showed you're half done, because you draw an arrow into space, it's incomplete. You have to combine two electrons, and then one more arrow showing that the other electron of that original bond goes onto the carbon. So that's our reaction arrows. So we have to draw out the product. This is, of course, now going to be a radical. It's going to be a CH2 because that hydrogen has been extracted. And the other product is indeed just HBr. Okay, so that's our first step. A bromine radical has extracted the hydrogen, leaving behind an ethyl radical. Now, in the next step, that ethyl radical is going to react with another molecule of bromine and continue what we call a chain reaction. So here's our bromine, and now again we're going to take three arrows to draw out our movement electrons. So again, you click here, one point in space and another point in space. That one half tells you that you're half done. So now you click here, point in space, and then click on the original one half, and the half goes away. You've now shown the formation of a new bond. The only thing that's left is to show where the other electron of the bromine goes. It goes to the other bromine atom. So when we're done, what we get here now is a mole of product, okay, where the bromines combined with the ethyl radical, and we form another Br dot. So again, I can duplicate the Br dot, move it down here. So this completes our propagation. So how does this work? We initially make a bromine dot. We just need a little bit of that, because that bromine dot, that bromine radical, extracts a hydrogen, forms an ethyl radical, and a mole of HBr. The ethyl radical reacts with another mole of bromine, produces another bromine radical. So this thing comes back up and reacts with another ethane. So this is why we call it a chain, because the product of the first reaction is the reaction of the second. The product of the second reaction is the reaction of the first one. So it just keeps kind of going around in a circle. Now, of course, eventually this will leave, because if these radicals do anything else than what I've shown here, the chain will stop. For example, if we had one of these radicals just reacted directly with a bromine radical, now this can also happen very readily. You could do this step. Okay. Again, we just draw an arrow in space. So those directly react, and this would give us another mole of ethyl bromide, which is the product, but it doesn't form the chain. So this is what we call a termination step. There's other termination steps as well. A Br dot and a Br dot could get together and reform bromine. That would be terminate. Or in fact, two ethyl radicals could get together and form a mole of butane. That wouldn't be very likely, but again, it would terminate the reaction. So radical reactions are fairly complicated, but drawing them, it doesn't have to be complicated. It's just that these fishhook arrows have this little bit new feature where two arrows meet in space to form the new bond. So not too bad, just practice a little bit.